Cheers and welcome back to Solar Phenom Training, where the smart get wise and the wise get wiser. Part 3 is solar PV electrical panel limitations. In review, we've dissected this homeowner's utility bill. We've figured out that this homeowner uses 1,500 kilowatt hours per month. Their average utility bill is $245 per month. And their average kilowatt per hour price is 16.3 cents. We've designed their roof to max out what their panel capacity could be. We want to offset their utility bill at 80%, which is a peak shaver program, which we would like to get the homeowners out of tiers 3, 4, and 5 for sure, and then maybe tier 2 if it makes sense monetarily. 1,200 kilowatt hours is what this homeowner needs at 80% bill offset. We've figured out longhand that this homeowner needs a 8.96 kW system. Solar modules are approximately 20 square feet in size. Their west-facing roof had 602 square feet at 30 modules with a 253 degree azimuth. That was max. Their south-facing roof was 140 square feet, 7 modules at 162 degree azimuth for a total of 37 modules times 250 watts at a 9.25 kW system. Our next step in the process is to make sure that what we have sized for their roof, we will be able to backfeed to the grid. So there's a 120% rule in electrical panel solar issues. So a 100 amp cabinet at 120%, we can backfeed 20 amps. On a 200 amp cabinet, we can backfeed 40 amps. On a 400 amp, we can backfeed 80 amps. So just real quick calculator, 400 times 0.20% equals 80 amps. That's how you would figure that out. So now we actually need to go and take a look at this homeowner's panel. So the first thing that I do when I open up the cabinet is I take a look at the tag on the inside. Sometimes there's no tag because of weather conditions or the panel got wet and the tag fell off. Hopefully there'll be a tag inside the panel. This also tells you the type of panel that it is, the type of breakers that you need to be able to put in there, and all the other information that that panel has. This panel has a main rating of 200 amps max, which means that a 200 amp max main breaker can be installed into this panel. If I look at what their main breaker is in the panel, it is a 200 amp main breaker. I look at the overall panel itself, I need to make sure that they have 2 empty spots. This particular homeowner has 7 empty spots, which is perfect. I only need 2. If you come across a panel that has full breakers all the way up and down, and there's no empty spots, the possibility exists that we could end up squeezing some of these panels into, so this panel would be, this is a double pole breaker. We could put that into a twin breaker, which means that we take this breaker and consolidate it into that and create a space. There's other conditions that apply that we can figure out a way to put 2 spaces in this panel. So we know that this is a 200 amp cabinet and a 200 amp main breaker. One of the other pictures that you need to take when you're doing your site analysis and your electrical panel limitation is to take a picture of the meter so that we have this meter number, and that applies to rebate processing and all the other paperwork that you are going to be required to produce to be able to close the homeowner and eventually get the system installed and everybody to get paid. So now we go back to our sheet. We know that this homeowner needed a 9.25 system. We originally had them down at 30 modules west facing, 7 modules south facing. We need a total of 37 modules. I go to my stringing chart. This is my hand wash stringing chart. 37 modules doesn't string on a central inverter. 36 modules strings on a central inverter. So 3 strings of 12 on an 8,000 inverter. 3 strings of 12 on an 8,000 inverter. I know that I could only fit 30 modules on this roof before, and 7 on the west facing roof. So 37 doesn't string, but 36 strings. Okay, so 36, 3 strings of 12. I can't put 12 modules on this array. Each string has to be facing its own azimuth. So I would need to put 12 modules on array number 2 and 24 modules on array number 1. I know that that can't happen, so it's not the end of the world. I just know on this particular job that I cannot put a central inverter on this home and make it string correctly. So now I'm going to revert back to in phase. So in phase, I can put whatever I want on any roof. I can put 1 module on a west facing roof, 1 on an east facing roof, and the rest on a south facing roof. But I know, because I already did my roof design, that 7 modules max could fit on array number 2, and 30 modules max could fit on array number 1. So if I go back to my stringing or my panel limitation spreadsheet, 20 amp breaker for every 1 to 17 modules or in microinverters. So I could fit 200 amp cabinet, 40 amp breaker max. I could put 1 to 17 modules for every 20 amp breaker. So I'm actually going to put 34 modules on this homeowner's house. 34 modules gives me a max of 40 amps of solar backfeed. They have a 200 amp cabinet, and I could fit 40 amps of breakers in there. So back to my spreadsheet. So I'm going to actually take this down to 27 on array number 1, and I could fit 30, so 27 is good. 7 on that. My type of modules are hand was. My type of inverter is an in phase, and then the number of inverters I need is 27 here and 7 here. So I hope that makes sense. As far as I couldn't use a central inverter because I couldn't put 12 modules on this array. I could put 24 on this one, but I need another 12 on in one array facing one azimuth. Every string needs to be facing the same azimuth. So for instance, if I had 2 strings of 10 modules would have to face 162 degree azimuth, and 10 modules would have to face 252 degree azimuth. I can't split my strings into different azimuths. I can't split any string at all into a different azimuth. Even if I have 1 string of 11, those 11 modules need to be facing the same azimuth. So back to my notes. My notes was a long wire run. No. Does the homeowner want an attic conduit run, which means that they don't want any exposed conduit on the roof? I'm not sure yet. Do the homeowner want the conduit painted? Absolutely. We always paint our conduit to make it match the color of the stucco. And is it a ground mount? So my sheet is almost filled up. I have all of the conditions that are met. My panel manufacturer size was a square D. So square D. It was a 200 amp cabinet. And you could do it however you want. You can normally you're going to have the sheet printed so you could circle it. The roof type and the age, I really don't know, but I know what year the house was built. This house was built in 2005, so I know that the roof is less than 10 years old. Do they need a panel upgrade? No, they don't need a panel upgrade. Any notes? I'm going to put just my notes are going to be plenty of room in panel for solar backfeed. So I'm on my way to designing this system. My next thing that I want to add onto this spreadsheet is a actual drawing of the roof, so that when my site engineer goes out there, he will know exactly where I have placed the modules on the homeowner's roof. Okay, how do I let the site engineer know where I placed these modules? We can draw it in on our sheet if we wanted to. Just draw print it out, sketch it, and just actually, place, just do your little sketch and show them where you wanted the modules. Or a little bit better way is we could go, everybody on the computer has a snipping tool. You just search for snipping. Here's how I do it. So I bring up my snipping tool, I take a little snippet of that home right there. I use my, you can use a pen if you want, red pen, black pen, or whatever. So I'll usually just put 27 right here, and then 7 right here. And then if you wanted to get a little bit more creative, you could just do something like this. Just that, you got 27 modules there. The biggest thing is you're letting the site engineer know where you've placed the modules, so that he can measure these roofs and make sure that your modules will fit, which you've already done your homework, and hopefully they'll fit, but you never know. We've definitely done our due diligence in making sure that this system will fit on this homeowner's roof. So it's 27 modules there, 7 there. You're going to use microinverters. You can basically Control C, which is copy. Go to your spreadsheet, hit Control V. You drag that down, shrink it, insert it onto your spreadsheet, and you're done. So now we have, on our site audit form, we have collected all of the homeowner's information. We have dissected their utility bill, dissected their roof. We have figured out that their 34 modules is what we're going to sell this homeowner. We're going to produce a certain amount of kilowatt hours per month based on azimuths of 253 and 162. We've told the site engineer where we've placed the modules, 7 on one roof, 27 on the other. Picture is incorporated in there, so that if he gets to the job site and the house doesn't match what our picture shows, then we've done something wrong, or the address isn't right. So this is just, I like to do it this way rather than draw it up, and it's real quick and easy to do it with a snipping tool from Google Earth. Cheers for now, and that is the end of part 3, and happy selling, and see you next time with Solar Phenom.